Welcome to Help the Hackers Get Your Data. I'm so glad that anybody actually showed up, as I'm up against Damien and the other guys. So, for starters, who am I? My name is Srđan Vranac. I'm the founder and team lead of Code for Hire, a small consultancy of heavy hitters. I've been in this business for 20 years. I make developers very uncomfortable and engineers very happy. Also, I'm a father of two beautiful girls. One is 9, second one is now 4 months old. So if I'm not in front of a computer, I'm out and about with my family, getting lost on some trail. So, as the input fields on the conferences are usually very short, this is the full title of my talk. Help the hackers get your data if you want to experience some very unpleasant things, and depending on whose data they get, even face jail time, right? As I said, I'm a cynic. I speak sarcasm as native language. The fact that I have been doing a lot of rescue projects has not helped this situation. So, for starters, let's manage some expectations, right? If you're still searching for the difference between a junior and a senior developer, this talk is not for you. If you're expecting some kind of DevOps, hardcore security talk, you're in the wrong room, right? If you're working in fintech, I don't think there is a part of this talk that you haven't heard and that you haven't used on a daily basis. So I honestly hope you will be awake. For the rest of us, yeah, we know that security is important, but do we really understand the fallout of poor security practices, or in this specific case, poor secret management practices? And take note, every time I say you, I mean we, because I'm out there with you, I'm making the same mistakes, I'm trying to be better. We deal with too many secrets on a daily basis in our lives, in our professional lives. Some of these are not so important. Some of those are very important, like your database credentials, like your third-party access, etc. But we don't think about those things. We shove them in our config files and move along, right? Your average developer, when you talk about security to them, they go like XSS, CSRF, OWASP, you're done. I don't care, right? We have conferences talking about code quality, about new things, about, I don't know, whatever. But, yeah, covariance, contravariance, architectural things, how to put it together, how to put together a better system. But people actually talking about the business fallout of poor secrets management, not even once, right? On top of that, when I started talking to C-suite people about this, they go like, yeah, this is awesome. You should really talk about this. When I talk about these ideas with your average developer, they're like, yeah, it's not important, right? So, I'll be talking about secrets management while trying to look at them from a business perspective, which means that this talk is aimed at developers who want to become engineers, because in 2019 and beyond, a good software engineer has technical skills, has communication skills, and has business skills, right? Unfortunately, in this industry, it sometimes comes with the stigma of unclean. Because, you know, suddenly you need to talk to business, and that's not a good idea. This topic is going to be a whole new talk, which is going to come next season to a conference near you. And hopefully you will walk out of this talk with some ideas and actionable advice, how to talk to your management about how to implement these things. What I'm saying is that you need to take off your developer's hat and put on your business hat, right? Because in 2018, GDPR came to be, we have HIPAA. Suddenly people are starting to wonder what data is collected, how it is stored, and basically cost of not handling security is too damn high. And here's your first takeaway. Cost and security are an afterthought, right? They are not an integral part of your application lifecycle. And that, of course, is bad. This happens thanks to the tunnel vision that is prevalent in this industry, which focuses on the quality of software, on architectural matters, on whether you're writing unit tests or not. And basically thinking about these kind of problems, they don't care because this is a business problem and not developer's problem, so it's not our thing. And this, of course, is a mistake that can cost a lot of money because you want to make sure that if, and this is not a uncertainty, this is a given, your server actually gets breached, you will be in a position to shrug and not go into the full panic mode. Because once you start thinking about security and secrets management in terms of costs and expenses, security starts to climb more and more on your priority list, right? And if you know how to talk to business or management about this, you will get their buy-in to do whatever you want because they know that you are going to bring value to the table and that you care about the bottom line. So as some of you, hopefully a lot, know that security is basically this wide subject. I'm going to focus just on one part of it for this talk. It is a low-hanging fruit. It's called secrets management. So, for starters, let's go about some data. On average, 1,793 unique keys are leaked to GitHub every day, right? As the man says, please spread the love. Commit your keys to GitHub, to Bitbucket, to other services. I mean, why put them in a single basket, right? I mean, let this sink in. Give it some time. I mean, it's wrong, right? You shouldn't do this, but you know, things happen, mistakes are made. Let's try another one. In the first 6 months of 2019, 4.1 billion records have been exposed in data breaches, right? If my math is not wrong, that is about 27 million daily. That's a lot, right? But still, you know, is it really that bad? Do we care? Why am I being so pessimistic, right? Let me put it this way. This kind of data points are what keeps me awake at night. And these are the things that I worry about how to improve and make sure that they are not messed up. Nobody gives a crap about your code quality or technical debt once data breach has happened. Then it's basically every man for itself and you better have your ass covered. So, what are the common ways of revealing your secrets? Short answer: incompetence, ignorance, and hacking, right? Well, that means that, or maybe long answer, that means that you leave your data sources exposed, whether it is your database, whether it is an instance of Elasticsearch, whether it is an S3 bucket, or you use Mongo. In most of the cases, it means that some poor soul actually got a task to set up the data store and they didn't bother with security because why would they? In case of Mongo, you don't care about your data if you use your Mongo, so I mean, why would you care about security? Personally, I think you deserve everything that happens to you. Sorry. Yeah, they're not a sponsor, so I'm good. All right, sorry. And of course, we have unauthorized access. Suppose somebody gains access to your server, right? And it will be done, right? Regardless of the setup, and I hope you have it. And if you're running Docker, Kubernetes, I'm hoping that you are running the latest version that has every latest CVEs patched, that you are not running it as root, right? And in case you don't, and in case you don't have an infra or ops team, which have their own setup for monitoring, this is basically the least that you can do. This is a tiny little script that is going to be executed every time an SSH connection has been made, and they're going to send you an email. And then you can ask people who actually need to have access to the server, like, are you connecting? If they are, awesome. If they're not, something's going to happen. right? Because the person who is actually accessing your server is now running on a countdown, right? They are supposing and assuming that you have a tripwire in place and that the alarm has started ringing. So now they are trying to collect as much data as they can and sift through it later, right? Of course, when you get the alarm and you get to the part like nobody who should be connecting to the server is not, you can actually shut the server down and take it offline and proceed from there, taking basically first action to prevent the bad actor and then do the analysis and see how much damage has been done. So if you have your secrets and credentials in your configuration or your parameters YAML or whatever, you just handed the keys to your kingdom to a hacker, right? And now you're about to experience very, very unpleasant things. From application being down to the cost of external security review to loss of sales to loss of your users' trust to potential litigation to God knows what else, right? Your code quality, your architecture will basically do shit for you, but your attitude towards security and secrets management just might save you. On the other hand, your configurations are always easy to commit to your repository, and then some weird stories happen. So I'm going to tell you two of them. One is a story that I found out by accident when I started looking into this subject, and the other one is what happened to me on a project that actually led to this talk. All right. So there was a person who was building a hobby project, right? They were trying to put together a prototype. They wanted to play with new techniques. They wanted to run it on AWS. So what did they do? They need an IAM key, right? Because why bother with security? They use the unscoped one, right? They shoved it in their configuration. They committed to the repository. They moved along building their thing. A couple of months pass. Purely by accident, they make the repository public for 15 minutes. Whole 15 minutes before they figure out like, oh, I'm doing something wrong. Let's make it private again. In those 15 minutes, somebody actually scanned the repository, retrieved the key, and at the end of the month, the person who committed that key got $15,000 AWS bill for 15 minutes of availability. That is about $1,000 a minute. That's a nice chunk of change, right? The other story is basically what led me into this mess. So a bit of a setup. Imagine a distributed system that works 365 days a year, 24/7, crunching numbers, crunching data, right? You have a lot of workers happening, you have a lot of things going on, and the key part of the system is that every morning when the morning shift comes to work, they have fresh data available to them so they can work, right? So one day we get an email, and of course, I'm sorry, I forgot to mention that, it's running on AWS. I mean, what else, right? So one fine morning, there is an email from Amazon. One of your AWS IAM keys has been caught in the wild. We never figured out how, because we really actually paid attention never to get them committed, but somebody did a stupid thing. So we go through our audits, we figure out that IAM key is no longer used. We send an email to Amazon, they say fine, we say fine, everybody's happy, we move along. Everything is fine. Awesome. 6 months later, again, one fine morning, 6 o'clock, I get up, I make my coffee, I sit down in front of my screen to check out the dashboard on the production system, and I see that something is wrong, right? Because I have a lot of these gauges, because we're using Datadog, shameless plug. I see that counters are not sending the data, they're not receiving data. And those counters that are actually sending the data, they have their thresholds, and we are way above those. So something is wrong, right? I log into the AWS console. We're using Spot instances because they are dirt cheap at that point. There is still no ECS and Fargate at that time. So we're using Spot instances to get our computing power and mass. There are no Spot instances, none of them. To make matters even more fun, there is also no Spot instance requests. Oh boy. I'm trying to spin up new EC2 instances because now I need to compensate for the power that I lost. I cannot spin up any new resources. Okay. I have what I'm currently running on EC2. That's it. This is trouble, and this is going to be a long day, right? I'm trying to contact the Amazon support. I'm not getting back any response. 3 hours are gone. 3 more hours until the morning shift arrives at this point. I'm making a call. Like, I'm going to call the CTO because they're in eastern part of America, eastern seaboard. I'm calling them because it's oh, sorry. Thank you. So basically, it's as o'clock at their time. I got to their phone. The phone is ringing. The phone is sending me to to voicemail multiple times. Nobody picks up. Okay, so again, trying to contact Amazon support with my phone number, but because my phone number is not on file, they're not calling me back. I'm trying to redline whatever resources we have, like shove it way above acceptable thresholds, trying to at least get a part of the data available for the people. And now it's 6 a.m. People are starting to roll into work. CTO wakes up, sees the missed calls, he goes online, we start talking, and then I realize I just had a masterclass in chaos engineering. So, the email that was used for AWS support is not an email that he uses often. He uses it maybe once a year. It took him a couple of hours to actually dig out the password, which was fun. And it turns out that AWS support actually contacted him because email was on file, right? And again, because there was no reply, nothing could be done. So he contacts the AWS support, starts talking to them, clears it out. We're happy. We are going to maybe get reinstated. Another 2 hours pass. We are now in hour 8 of the outage. And now the information is starting to come in about what happened. So that key from the beginning of this story that Amazon said was fine and that we said was fine was for some reason flagged in a back audit. And Amazon decided to protect us by blocking our account. And of course, they used the email on file to notify us, right? Okay, so now everything is cleared. The account is going to be enabled in the next hour or so. I ask about the Spot instances and Spot instances requests. Amazon says no dice, because their policy is to shoot first and ask questions later in cases like this. Basically, they deleted everything. They wanted to protect us and not incur cost. I mean, next couple of hours, and this is on me, I'm putting things back together because I haven't automated it. I never thought that something like this could possible. Now I know better. So 16 hours later, we are back in business and operational, right? Can anybody guess what's the damage? Ballpark it. For 16 hours of outage. All right, $1 million. For 16 hours of outage, $1 million of loss in revenue, and daily wages for some 300 people that are going to be paid, but they didn't do anything because we didn't have data for them. Yeah, fun stuff. And this is basically how I got into this whole talk. But you know, back to the subject. You're smarter than that. You're not shoving your secrets into your config files. You're using environment variables. Yeah, awesome. Good for you. I mean, what could possibly go wrong, right? You have your local development environment file. You have your staging. You have your production. They are not being committed because you're ignoring them, etc., etc., etc. But still, I mean, people do stupid things in production. What could possibly go wrong? Right? Do I need to explain what happened here? Yeah. This is at least a year old, but still, it's valid. If you run the search, you will see a lot of things. Right. Again, even if you don't have your environment environment variables, like unindexed and used properly for a skilled person that gain access to your server. Basically, this is the command that they need to do to list them out. But you're using containers. Yeah. So you're shoving your environment variables directly into your Docker engine. Then I can use something like this to basically list them out, which again brings us into the same thing. And are we going to even talk about the ever-increasing mess as you need to increase the number of configuration values that you pass, how bad that is, and how big of a mess it becomes? And if you're using a Docker compose file, basically it starts looking like this. And I mean, good luck to you keeping this monster tamed, right? Oops, sorry. I mean, even better question. When you add things to the Docker compose file and you pass it to your developers, how do you share the newly added values? How secure is your system? Are you sending them via email or are you using some chat application? How bad is it, right? But sure, we are going to switch to Docker secrets, right? Right. You're telling me that you want to use a file-based clear text located in run secrets and then variable name, right? Please, tell me more about this security. I would really like to learn. Even if you squint and pretend that this is not an issue, right? You still have to keep in mind that some Docker images contain vulnerabilities, right? And you're all inspecting them before you're running them loose in production, right? You're not playing Pokemon, gotta have them all, right? Sure. If you have an ops team that allows this, please have a talk with them. And make sure that management or business is present. Because you need to explain to them why what they're doing is bad and that they need to improve, right? Because consequences of these kind of actions are long and strong, right? Up to this point, we talked about some concepts, but I haven't used their names yet. So for those of you who still haven't figured out what I'm going to say, here they are: liability and criminal negligence, right? So here's an idea. When you get back to work, run an experiment. Ask your boss, manager, whatever, for a meeting, and ask for a company counsel or lawyer to be present and sit down with you. Because you want to talk about what happens in a case that somebody sues you because of a data breach, right? And then you get into a talk. And then at one point you're going to explain how data breach can happen. You say, hey, maybe somebody gets our credentials, right? And then somebody is going to ask you, what do you mean? And you say, well, we store them in config files or environment variables, right? And they go like, but okay, what does that mean? And you're going to say, well, that means that everybody who can get that file basically can open it and read it. At that point, just sit back, relax, and watch what happens, right? Just enjoy that moment, because after that, you're going to probably be introduced to a nice term called criminal negligence, right? But hey, we have insurance, right? This is not an issue for us. Are you sure? Are you sure that your insurance actually covers case of data breach? Cyber attack, maybe. Liability from third parties, most likely. Data breach, not so sure, right? Even if that you think that is not a problem, once you have to claim it, then you have to explain your reasonable security practices. Then you're going to have a lot of fun. And when it's time to adjust your premiums, again, you're going to have to explain your reasonable security practices. You got this, right? It's not going to be a problem. Not to mention that there is a part in every contract that says exclusions, and I'm almost willing to bet that there is a section that goes something along the lines, if anybody in this outfit actually knew that this could happen and did nothing, we're going to prevent the payout. Yeah. So read your contracts or ask your boss. Right. Of course, there is also the case of certification, right? So you have your application that is starting to take off, and suddenly a major client appears and they want to close a killer sale. They only have one condition, Do you have ISO 27000 certification? Right? Suddenly you're going to learn that your secrets management and security practices are a costly business, and if you're not paying attention from them from the start, this is going to be a long, long time before you actually get to a point where you can actually close that sale. And it's not fun, right? This is why I'm talking about a cost and security together, because more often than not, they are the same facet of business, and that is basically cost and damage control, meaning that you need to maximize profit by not losing sales and decrease your liability potential, right? So how can this situation be improved, right? It's kind of easy. Use secret management applications. Hooray, right? So what are they? What are the features of a good security application? Well, first of all, it is ease of setup and operation, right? You want to use something that is relatively straightforward to use and that people can set up without too much reading of the manuals and having some cryptic configuration files. You should also have like a clear path to upgrade to high availability solutions, right? Or multi-data center. And the way that your application interacts with secrets management should be as straightforward as possible. Secret rotation is always a good idea. It's nice to have a secret that expires. It means that you're going to have some kind of security in the long run, right? As far as your application is concerned, again, it sends out the request, a new data comes in, it doesn't care whether it is stale or not, it just works. On the other hand, the ease of change of these things really matters a lot, because if it's straightforward, people are going to spend less time on it, so you're going to have less cost, right? And dynamic secrets. This is my favorite one. On top, on the surface, really not that important. But when you start thinking that now you have a secrets management application with dynamic secrets, which means depending on the authorization token that you emitted, that you can get different data, means that you can have different values for production, for staging, for testing, for local development environment, which means that part where we talked about having a huge Docker compose file that is basically making your team stop and waiting for them to get access just goes away, because now it's centralized and they just emit their token and get the data that belongs to them, which can significantly cut down cost. So, do I need to say anything about this? This should be clear. I mean, if after the GDPR mess you're still not clear on this, I'm sorry, you're beyond redemption and salvation, so not my problem. And of course, choices of backends. This kind of can be important depending on your setup, whether you want to use like a local store, or you want to use some kind of RDBMS, or you want to use a multi-data center or whatever. It's nice to have the ability to mix and match so you can be actually being able to tailor it to your needs. And of course, cost. We would all like to have cost zero. Basically, for it to be free, unfortunately, that's almost impossibility. But what you could do, and you can do a lot about it, is control the cost that you're going to incur. Which means how many billable hours are going to be spent to configure this thing. How many billable hours are going to be spent to set it as a high availability solution. How many billable hours are going to be spent just maintaining and stuff like that. Again, by having dynamic secrets like that, you make savings on other ends, but still, it's still good. Now, this is a list of some of the secret management tools out there. Just like a fragment of them. There is a lot of them. They are now, well, we can call them mature because they are not there. They have been around for like 2 or 3, 4, 5 years, long time in our industry. Some of them good, some of them weird, to put it mildly. I actually encountered one of these applications, for the life of me I can't remember which one, that expected me on every change of secrets and configuration to recompile the application and then deploy it to the server, which like, no. So we're going to take a look at two of them because AWS is like the ever-present beast around us. This is one of 3, I think, that they have. So this is their native way of storing secure static key value pairs, right? It does have some rotational ability. Outside of AWS and RDS, you have to like write that for yourself, which makes it unusable, but it is also single region only. Now, if that is not a problem, there is always a cost because it can like wildly vary depending on your use. So here's one example. This is a production scale web application. Nothing special to SSH key, 7 API calls, yada, yada, yada. $6 a month, right? $6. Not so much. But when you use microservices, oh boy, right? So AWS is basically a bottomless pit of sorrow for the bills. I mean, you never know what you're going to get. And this is basically taken from their pages, like from their official documentation. I have been reading this for like 3 hours or so, and I still couldn't figure out, so I just copy it and bold the result because people understand that. Right? So, of course, the other tool that we're going to mention here is Hashicorp Vault, because this is something that you're going to hear a lot if you start talking about infrastructure management. So, why is it a good fit, right? Small binary. Configuration is relatively straightforward. It has secrets rotation. It has dynamic secrets. You can add SSL certificates. You can have nice secure transport and decryption at rest and everything. It can be done by a single developer or a non-infra person. You have HA availability out of the box, so you can upgrade your solution as need. And of course, you have choices of multiple backends, so you can tailor it to your needs, right? And of course, it has this thing called, I love saying this, I never get it right, SHAMIR'S secret sharing algorithm, right? And this is kind of like the secret sauce to get it running. SHAMIR'S secret sharing algorithm is basically a way to distribute your secret in such a way that multiple people going to have a piece of that secret, and then when you define a threshold, which means how many pieces of that secret are needed to be present, you can then unlock the vault, and then you can start using your data. That means that you now have an elegant solution to unlock and prime your vault and or your secret storage if somebody is on vacation or something happened, a bus factor or like whatever. Now you can actually access your secrets in case of bad stuff, right? And Vault also operates exclusively in whitelist mode, which means that unless you have explicitly granted access to a variable, you will not get it. Now, thing is about Vault, you can define multiple policies per user, so you can actually fine-grain your controls and access. That allows you to be happy on one end, and on the other hand, kind of miserable because you can easily screw it up. So you need to be careful. So if everything is so awesome with Vault, are there like real problems? And yes, they are. 2 of them are going to come to surface very, very soon. And one is your procedure for sealing and unsealing your Vault. Because every time an application restarts, and that's not often in my experience, but it can happen, how are you going to unlock it? How many people need to be available for the Vault, for the threshold to be reached? And how many people actually have access to pieces of those keys? Like CTO, owner, lead developer, what happens if he goes away? Who's going to replace him? And stuff like that. You need to think about that. And the other thing is HTTP calls. And this is kind of like, what do you call it? A loaded question. Because Vault basically communicates with HTTP requests, right? So it means that if your network stack is overtaxed, sometimes you might encounter latency. But then again, I mean, you can either do something about it, but if you can't, Not having latency or having a peace of mind and sleeping well, I think the choice is clear. Of course, the real answer for the second one would be to use HTTP2, which means that your overhead basically becomes zero, so it's not a problem. So let's see how it all fits together. If you remember that story about the part about basically accessing the server. So a Vault token goes into the configuration file. Yeah, I know, ironic, no. The token gets sent to the Vault server, and you basically get a client token, which is kind of like a cookie, which you use then to get all the data. And only the retrieval of the secrets that are granted by the ACLs is possible, right? And when leased on the client token, the cookie expires, the Vault token is used to obtain a new one. So, kind of straightforward. In case of breach, your tripwire system gets triggered, your files are downloaded, possibly configurations. It happens, of course. You remove the server from public. And here is the important part. Now you're running on a countdown timer because you are trying to get ahead of the curve, ahead of the people who got your data to actually rotate your secrets and make it secure. So with using Vault or something like that, they're going to have a big cryptographical challenge to actually get the data. And if they can, I mean, then you have a lot bigger problems than this. So you can rotate the token and the secrets in your Vault, you can update the config, and you make the server publicly available, and you move along with your life, right? So, would you use secret management on every project? Well, that depends. If I'm in a position to make the decision, I have like a checklist like this, whether we are collecting user data, some kind of personal identifiable information. Yeah, sure. Are we using any kind of sensitive data? Yes. Are we using any kind of payment system or something like that where we have to keep any kind of PCI compliant data? Yeah, definitely use secrets management. As I said, if I'm in a position to make the decision, I go through a list like this and I make it. If I'm not, I present my case to the management. They can do a cost-benefit analysis, make a decision. If they want to go for it, awesome. If not, awesome as well, more props to them. I just like to have it in writing that I presented the case and they declined, because when it hits the fan, my ass is covered, right? So, final words. Even with the potential drawbacks of secrets management application and such, I think it is valuable to invest your engineering hours and company time to have it secure, because you're going to sleep a lot better and your data is going to be more secure. Because according to IBM Security, average cost of large data breach, which means by their definition is that more than 1 million records are lost, in 2018 was $3.9 million. That's a lot. And if you remember, we were talking about in the first half, 4.1 billion records are lost. That's $27 million a year. So that basically means that 27 large data breaches daily happen. That's quite a chunk. And we're talking about here about the costs that are not directly visible. We're talking about the cost of security audits, about the PR companies that are going to be needed to manage the public opinion, the cost of revenue, the cost of hunting down the bugs, the cost of fixing this, the cost of repairing this, redeploying this, and everything else. I really, really think that it is significantly cheaper to invest engineering time in something like this and to fix this low-hanging fruit than actually have it run its deadly course. Thank you.